This video is on constructing and interpreting numerical data displays. There are many different ways to display data visually. In this video, we're going to take a look at 3 different ways of doing that. The first is a stem and leaf plot. It's a table in which each data value is split into a stem, usually the first 1 or 2 digits, and a leaf, usually the last digit. Let's take a look at these pictures here. The first image is a single stem and leaf plot. You can see here are listed the stems and here are listed the leaves. And the second is a back-to-back stem and leaf plot. You'll notice that the back-to-back stem and leaf plot is useful for comparing 2 different sets of data values. Notice that they have common stems in the center, and then the leaves for brand B are listed off to the right, and the leaves for brand A are listed off to the left, kind of in reverse order. One important thing to notice about both of these stem and leaf plots is the key that's at the bottom. Notice that the key for the first one, since this is race running times in seconds, the first 2 digits are the whole number of seconds, and the leaf is actually the 10th of a second. Over here in our phone battery comparison, the stem is like the tens digit because a stem of 6 and a leaf of 1 is equal to 61 hours. So my stems are all the tens of hours, and my leaves are going to be single hours. So for example, this value right here would refer to 56 hours. So let's go ahead and make a stem and leaf plot from the data values below. And so here's a set of test scores, and I need to make a stem and leaf plot. So I'm going to start with kind of a T-chart here, and I'm going to call these my stems. And then here I will have my leaves. I don't like that. Okay, and I'm noticing that my data values, I think it looks like my smallest one I have a 64 and my largest one is probably a 99. So I'm going to go with stems of 6, 7, 8, and 9. Now you could take and line all of these up in order, or you can just go ahead and list them and cross them off the list as we do that. So this 64 value right here is going to be a stem of 6 and a leaf of 4. And then what do I have next? I have a 77, so that's going to give me a 7 here, and I have a 78. And then in the 80s I have 2 83s and an 85. And then in my 90s, I have a 92, a 97, a 98, and a 99. Notice that I tried to keep these in columns so that it kind of shows me, I can visually look at it and say there are more values in the 90s than there are in the 60s. And then I want to create my key, and I'm just going to choose any value. So I could say 92, so a stem of 9 and a leaf of 2 is equal to a 92%. So that's how to create a stem and leaf plot. Another type of plot is called a dot plot, and that's a graphical display of data that uses dots for the data values, and those are listed or put over a number line. So my first image here is of a single dot plot, and the second is a double dot plot. Notice that again with the double dot plot we have the same number line kind of lined up exactly the same so that I can compare, for my 2 hours and my 4 hours and so on. Just makes it a little easier to compare those data values. Each dot represents one data value. So for example in this first dot plot, so we have the fact that there are 7 dots over this 50 means that there are 7 boxes of matches that had 50 matches in each box, and there were 3 boxes of matches that had 51 matches in each box. So let's go ahead and create a dot plot from the data below, and this is the number of students in each class, and I have a lot of values here, so I think I'm going to go ahead and take the time and list these in numerical order. So I think my lowest value is 25, and then I have a 27, and I have 128, and then I have 1, 2, 3 29s. Sometimes this is the hardest part. And then for 30s, I have 1, 2, 3 30s. And I have 1, 2, 3 31s. Oh, wait a minute, did I miss a 29? Oops, I actually have 4 29s. Oops. And then I have a 32 and a 35. And I'm going to go back and count. So 2, 4, 6, 8, 10, 12, 14, 15, 2, 4, 6, 8, 10, 12, 14, 15. Okay, good. I do have all of them. Now I'm going to create a number line. And my smallest value is 25. My largest value is 35. 30 is going to be somewhere in the middle. And I can go ahead and do like 26, 27, 28, 29. Try to keep it even if possible. 30, 31, 32, 31, 32, 33, and 34. Okay, now I have 125, so that's going to represent a dot there. 127, 128, and then I have 4 29s. And I have 3 30s, and notice I'm trying to keep them, the second ones are at the same height and the third ones are at the same height. That's just going to make it easier when I'm looking at this and trying to compare. And then I have 3 31s, a 32, and a 35. And there is a single dot plot. And you can see by looking at that where most of the data values are kind of centralized around 29 and 30. And the third type of plot we're going to take a look at is called a box plot or a box and whisker plot. And this is based on a 5-number summary of a set of data. The 5-number summary consists of the following 5 numbers. The minimum, which is the smallest data values when the values are listed in numerical order. The lower quartile, or sometimes called Q1, and that is the middle value of the lower half of the data set. The median, that's the data value that's in the middle when all of the values are listed in numerical order. If you have an even number of data values, then you're going to find the mean or the average of those 2 middle values, and that's going to give you your median. The upper quartile, or Q3, is the middle value of the upper half of the data set, and the maximum is going to be the largest data value in your set. So here's what a couple box and whisker plots look like. The first one is a single box and whisker plot, and the second one is a double box and whisker plot. And notice that as with the double dot plot, we have a single number line so that we can compare the data values and the plots. So let's take a look at this first, this single box and whisker plot here, which talks about the number of eggs laid. So looking at this, I can tell that my minimum value is 2, my maximum value is 10, my median is 6, and my first quartile goes from 3 to 6, and my second quartile, or actually third quartile goes from 6 to 8. So that means that this value of 3 right here is the middle data value between 2 and 6. What I don't know looking at this is exactly how many data values there are in each of those different ranges. So the box represents what we call the interquartile range. That's this between Q1 and Q3. The whiskers extend out to the maximum and minimum values, and this vertical line going through the box represents the median. So let's go ahead and draw one. So let's create a box and whisker plot from this data below, and these are some midterm test scores, and I've already gone ahead and put them in numerical order for you. So let's go ahead and identify our 5-number summary. So my minimum value is 41. My Q1, I'm going to hold off on that for a minute. My median, my Q3, and my maximum, which is 100. Those are the easy ones to get. Now the median is the number that's right in the middle, and I believe I have altogether here 20 values. So 2, 4, 6, 8, 10. Did I count right? Hold 2, 4, 6, 8, 10. So that would be right in the middle right there. 2, 4, 6, 8, 10. Yes. So my median would be that value right in the middle there. So I need to actually, since there's an even number of values, I need to average those two, and that's going to give me a 78. Now that means that this here is my lower half of the data set. To get my lower quartile, or my Q1, I need the median of that data set. So that's going to be between values 5 and 6. So the average of 67 and 73 is actually 70. And then my Q3 is going to be the median or the middle value in my upper half of the data set. And so that's going to be right in between here. And the average of 89 and 93 is 91. And that's enough information to go ahead and draw my box and whisker plot. So I'm going to draw a number line. And I need this to go from 40 up to 100. So 40, 50, 60, 70, 80, 90, 100. I made that a little small, but that's okay. Okay, and my minimum and maximum values are going to be the ends of the whiskers, so I put dots on those values. And my Q1, my first quartile, is 70, so I'm going to put a dot there. My median is 78, so I'll put a dot there. And my Q3 is 91, so I'm going to put a dot there. So now I'm going to draw a box that represents the interquartile range, and that goes from Q1 up to Q3. And draw a line through your median value, and then go ahead and draw lines out to your whiskers. And there's your box and whisker plot. Each of the dots has one value in the 5-number summary. And looking at this, actually, it's really an interesting set of data, because what this box says is that 50% of my data values are right in here between 70 and 91. So that's where most of my scores are. This 41 way down here, and in fact you can see there were just a few that were very low, are almost outliers. They're way out there, kind of away from where most of the data is. So in this video we took a look at some different ways to numerically display data using a stem and leaf plot, a dot plot, and a box and whisker plot, and did a little bit of interpreting of what those visual displays tell us about the data sets.